Hey there, stats enthusiasts. Welcome to our very first video in our course on AP Statistics. I'm Goldie, and I am here to take you through this entire course on AP Statistics and teach you all of the foundational concepts you'll need to be successful in this course. We are starting with our very first lesson today on Notes 1, which is going to be about categorical data and how we display it using tables and bar graphs. Now, our objectives from the CED today, we're going to talk first about variables and just kind of the language we use around variables, and then representing a categorical variable with a table, and then with a bar graph as well. So we're going to cover all of those wonderful things today in our very first section of notes. So hang tight, pull up your notes if you have any to take down, and we will go ahead and get started. So what are statistics? When we talk about statistics are numerical data, but it's also what we consider the study of data. So we say statistics in the terms of studying data and what data means. Data is or are observations that have been measured, recorded, collected, analyzed, reported, any of the above for our use in some way. Now, data is going to contain information about groups of individuals. And when we talk about individuals in terms of statistics, it's going to be objects described by a set of data. So you're used to thinking of individuals as people, but we can also refer to animals, inanimate objects, all of these things as individuals as well. It's just what is being described by data. And information is organized using variables. Okay, so this information we gather on individuals is organized using variables. Now, there's a few different types of variables you're going to want to know for this course. The first one is broken down into two types of variables called categorical and quantitative. So obviously today's set of notes is called, representing categorical data. So how can we represent categorical data? Well, first we have to understand what a categorical variable is. Categorical variables are data that places individuals into groups. Some examples of categorical variables include gender, okay, where whether it's people, animals, etc., you can be put into different classes of gender. Colors, different colors, sizes, grades, political parties, all of these are categorical variables because they all have groupings that you can place individuals into. Now, quantitative variables are data that take on numerical values. So when we can perform arithmetic operations on them, and it just makes sense, like finding an average, finding a min, finding a max, etc. So these are going to be broken down actually into two more types, okay? Because there's a lot of types of quantitative variables out there. So we have two types that we're going to break it down into even further, and that's going to be discrete and continuous. So discrete variables and continuous variables both are quantitative, but they're different types of quantitative. Discrete variables is numerical data, quantitative data, where whole numbers make sense to describe the data. So variables where you would count and variables where decimals just don't really make sense for it. Okay? Some examples might be number of siblings, right? When we describe number of siblings, we use whole numbers. I have one sibling, two siblings, three siblings. We don't generally use decimals to describe, okay? Number of pets, same idea, or even things like a blood pressure, right? Blood pressure readings are given as whole numbers, okay? Even though we can potentially describe them with decimals, like you have a half sibling, right? Or things of that nature. We're looking at the majority of cases, number of siblings is going to be described as discrete, et cetera, et cetera. So continuous data on the other side is numerical data where decimals make sense to describe it. So this is where, if you're measuring something, that's usually going to be a continuous variable, like measuring with a ruler, measuring with a scale, something like that. When that's used to report values, it's going to be a continuous random variable, a continuous variable. I'm used to saying random variable, ignore that. Some examples of continuous variables include height, weight, or even time. Many different types of continuous variables we're going to be talking about, but those are some examples. Okay. Now, here's some things to remember with these variables that we just went over. Just because it does have a numerical value does not automatically make it quantitative. A lot of students fall into that trap. So off the top of your head, can you think of an example of a number that is categorical? Okay, if you can think of it. Like zip codes, area codes, okay, right? If you have a zip code, that zip code is numerical, but it is not quantitative because we don't actually measure zip codes. One zip code relative to another zip code does not have, there's no relationship between the numbers. So it's considered categorical. Same thing with area codes, okay? And any other example that maybe you could have thought of. And then past that, discrete and continuous, like I said, it isn't always clear, like number of siblings, right? You could have half siblings. So is that being described as a decimal or a whole number? What we'll run into a lot in this class is age, right? Is age continuous or discrete? Because age, we describe age as like, I am 16 years old, I am 17 years old, but we could also describe age as a continuous, right? Like I am 16.34 years old. You could figure out how many decimal years old you are, right? So does that make age continuous or discrete? Because we use whole numbers to describe it, but it can be measured with a decimal, it's a little unclear. So when you're looking at examples and trying to determine, is this discrete or continuous? Because the difference between the two is going to be, how do I display the data? How do I describe the data? You're going to want to know which is which when you're gathering data, right? If it's not obvious, think about how you're going to use the data, okay? So for example, if I'm recording age of individuals, because I don't usually report age as a decimal, like if someone asks me what my age is, I don't say I'm 16.4 years old, right? You usually say I'm 16 years old. So because of that, we treat age like a discrete variable, okay? Even though technically it could probably be continuous. You might run into a few different examples like that in this course. So just know that we're talking about discrete and continuous in terms of a broad general description of variables. There are examples like age that could go either way, but the important thing is, how do you use it? Okay, let's talk about categorical variables now. There's going to be two ways we are going to display categorical variables in this course. There's going to be other ways, of course, that you are going to be able to do this, but we're going to focus on the two ways in this course. The first way is a frequency table. Okay? Frequency table is a way to display how many individuals fall into each category of the categorical variable. Okay? We also interchange frequency and count often. Okay, so when you see the term frequency, all it means is count or a tally marking or how many fall in each category. Okay, now below I have an example of the raw data of a sample of teachers' favorite pizza toppings. When we talk about raw data and you see that term raw data, it's referring to data that's unorganized, that hasn't been organized in a nice way yet. We talk about raw data. So here's an example of our raw data. So this is 25 teachers who were asked what their favorite pizza topping is. So you can see when we talk about raw data, how there is just no organization to this. It is just data. And that makes it difficult to see counts, to see patterns, or just to observe what the data is trying to tell us. So that's where we turn to frequency tables to help us at least start to organize this data a little bit better. We're going to see a one-way frequency table, and we're going to focus on one-way frequency tables here. Later on, we'll talk about two-way frequency tables with categorical data. We're going to keep it simple in this section of notes and just talk about one-way frequency tables. So one-way frequency table starts off with the categories. So pizza toppings is the variable. The different categories it can take are the pepperoni, sausage, bacon, black olives, onions, mushrooms, and some crazy person put pineapple on pizza one time. So we have pineapple as a category. And then underneath that, you can see we have frequency. And as I mentioned before, frequency is also another term for count. Okay, so just know that. Now, what do? Well, I just go through and I count up how many fall into each category. So how many teachers liked pepperoni? There were 7 teachers who had pepperoni as their favorite. I was one of them, okay? Sausage, 5 teachers liked sausage. Canadian bacon, 3. Black olives, 4. Onions were 2. Mushrooms were 3, and one crazy teacher put pineapple down as their favorite pizza topping. So crazy. But that's going to be our one-way frequency table. Okay. So the frequency table, it shows the counts in each of the categories. What we can also make is a different type of table called a relative frequency table, or sometimes it's referred to as relative counts as well. So we just saw a frequency table. Relative frequency displays the percentage in each category instead of just the counts. So frequency displays the counts. Relative frequency displays the percentages. So a percentage would be like relative to the rest of the categories, what percent fall into this category, okay? So to find the relative frequency, you take the frequency in the category that we just found, so like 7 teachers like pepperoni, right? And we divide it by the total number of individuals in our sample. So in our case, we had 25 teachers, right? 25 teachers was in our sample that we took. So for pepperoni, since we had 7 teachers who liked pepperoni, 7 out of 25 gives us 28%. Okay. Now, if we usually relative frequencies, we do whole number. So we like round to the nearest whole number. In this case, it worked out to be a perfect 28%, but we try to round it just to make it easier to graph in the long run. Okay. But you might also have decimals too. It's up to you. Okay. Sausage, there are 5 teachers who like sausage. So that's 20% of teachers in our sample like sausage. And we go through and we do that with each of these categories. Okay. Pause the video, copy those down if you need to, but let's move on and talk about how we can start to graph this data, okay? So the most common way we display categorical data is with a bar graph. A bar graph is used to visually show what we call the distribution of data. So that term distribution is used to describe the visual display of data. And the visual display of data shows the data or shows the variable and then shows how often the data takes each of those values. So when we talk about describing the distribution later on, we're going to be saying, describe what patterns you see. Okay. Right now, we're just going to make it. Okay. Let's make a bar graph. To create a bar graph, you're going to want to first make that frequency table or relative frequency table. Either table would work. And then once we have that table, we can translate it into a bar graph. And here are the, steps you can take to make that. We draw our axes. So everything takes place in the, for a categorical bar graph, everything takes place in the first quadrant of a coordinate plane is kind of how you can think of. So when I say draw your axes, think of quadrant 1 on a coordinate plane. So you're going to have a vertical axis that goes up and then a horizontal axis that represents your x-axis. Now your x-axis is going to contain your categories. It's not going to contain any numbers right now because we're dealing with categorical variables. So your x-axis actually just has the categories listed. And your y-axis is going to contain the counts or percentages. Counts if you have a frequency table, and percentages if you have a relative frequency table. Okay. We draw a bar for each category on the x-axis that goes up to the corresponding value on the y-axis. Very important here, bars do not touch in a bar graph. There's no connection between the categories is how I like to think of it. So because there's no connection, they don't touch. Right? Versus a quantitative, we're going to have in a quantitative variable with a histogram, we are going to have the bars touch because there's a relationship between the numbers on the x-axis, right? One number comes before the next number, and there's a relationship. But there's no relationship between the bars, so they don't touch. That's kind of how I always liked to remember it, okay? Order of the categories does not matter. That's one of the things with bar graphs. You can have your categories go kind of anywhere on your x-axis. A lot of people like starting with the highest or starting with the lowest and going up from there. You can also just kind of have them haphazard across your x-axis. Whatever you prefer. That's you as the statistician or emerging statistician. That's going to be your prerogative there. So here's what we're going to show with our favorite pizza toppings here. We start with our axes and our labels. So first I have my x-axis here. You can see how I have the pizza toppings down here, pepperoni, sausage, Canadian bacon, etc., making sure to label that, hey, this axis, this is the pizza toppings, and then frequency here. Okay, so I'm just going to do frequency. Relative frequency, you can also do that, and you would just change your y-axis to be percentages. But you're going to want to label. And I make sure to go up to 7 because that's going to be my highest frequency here. But you don't have to always go to 7, right? It's always going to depend on your data and how high your data is. So I always say just look for your highest, right? Mark that as your highest, so 7 here, and then evenly mark the rest of your value. So it made sense to go up by 1. If the highest was like 100, right? It wouldn't make sense to go up by 1s if my highest value on the bar graph was 100. Okay, so it would make sense to go up maybe by 10s or even maybe by 20s if my highest number was 100. So you're gonna have to make sure that you distribute that evenly, okay, in some way. Here, 7 made sense. So I start off, pepperoni goes up to 7. The bars are not gonna touch, so I'm gonna draw each bar individually. Sausage gets 5, Canadian bacon gets 3, black olives 4, onions 2, mushrooms 3, pineapple 1. Okay? And here's the teacher's favorite pizza toppings, okay, as a bar graph. All right. And that actually brings us to the end of our lesson today. So thank you guys so much for following along with me on our first video in our first unit in AP Statistics. The next video is going to be over notes 2. So we're going to get into displaying quantitative data in the next video. Until then, if you like this video, please hit the like button or subscribe to my YouTube channel for more AP Statistics content. And until then, I wish you endless statistical success, and I will see you in the next video.